Hello my dear students, welcome back to the session. Last class we discussed some important definitions like average value, RMS value, form factor, peak factor and all those things, okay? So let's look at some problems based on average, RMS, form factor and peak factor calculations, okay? So the first question here in the classroom workbook, average, RMS, form factor, peak factor values of pure sinusoid, half wave rectified sinusoid, full wave rectified sinusoid. Okay, so let's look at the first one. So you know that what is a pure sine wave already, how you define the pure sinusoid, right? So the first one I deal with here, the sinusoid. It's a periodic waveform. Theta on x-axis, omega t, v of t. It starts from origin, let us say. This is v max and this is minus v max, okay? Minus v max. Let's define this. V of t is v max sine omega t, okay? Sine omega t between, because only first cycle we are supposed to define. This is pi and 2 pi and so on and so forth, okay? Sine omega t between 0 to 2 pi. Okay? Now, before we even define mathematically, we need to even define what is the time period. What is the time period t equal to 2 pi for this particular function? Always you define the waveform. Mathematically for one complete cycle. This is a standard, procedure to be followed. Whenever a waveform is given, whenever average, RMS, form factor, peak factor values are asked to calculate, the first step is define time period. In that time period, now you define that waveform mathematically. So tell me, what is 0 to 2 pi? What is the waveform nature here? Sinusoid. You already know mathematically how you define it. V max sine omega t. See, this is simple, but when any problem is given, this is the standard procedure to be followed. That is what my intention here. Okay. Now, once you define mathematically over one complete cycle, okay, and you know the time period, then you can calculate V average is nothing but 1 by 2 pi, because 1 by t, right, 0 to 2 pi, V of t dt, but not dt here. Whatever is there on the x-axis, that must be there here. With respect to that, you are supposed to integrate. So what is there in the x-axis here? Omega t. So V max sine omega t d omega t. What is V max sine theta d theta? That is also fine. What is this actually here? 0. Because over one complete cycle, you know that this value will become 0. Already you know very well, because it's a symmetric waveform. Now VRMS. Let us take VRMS. What is this? 1 by 2 pi, 0 to 2 pi, V max square sine square omega t d omega t. Okay, sine square theta d theta. It's fine, right? So you simplify it. Sine square omega t is nothing but 1 minus cos 2 omega t by 2. Yes or no, all of you? Then you integrate it. Then you substitute the limits. Then you get the final answer. I'm not really going to simplify it, because simple integration part, you guys can really take care of it. Okay. So I just directly write V max by root 2 is supposed to be your answer. Okay. Now let us look at the form factor. What is a form factor? Form factor usually defined as what? RMS by average. RMS value you know very well, V max by root 2. Average value is what? 0. Then if you substitute this here, it will be like infinity. But I told you already, form factor never be going to be, okay, it is never going to be like, infinity value. It's not a practical value. Okay. So therefore, for the sake of form factor calculation, the average value over, okay, half cycle is calculated instead of full cycle. I told you already, okay, that only for the sake of form factor calculation, the average value must be calculated only for a half cycle. Understand? Okay. Now, what is that? 1 by pi, 0 to pi, V max sine omega t d omega t. What do you get here? If you simplify, sine omega t is nothing but minus cos omega t. You substitute 0 to pi, it is becoming 2V max by pi. This is the value. Now let's find what is the form factor. Kf is nothing but V max by root 2, 2V max by pi by 2 root 2. It is 1.11 and so on and so forth. Okay, 1.11 is the value that you get here. Okay, now what is the peak factor? Peak factor is nothing but Kp. Peak factor, okay, it's not power factor, it's a peak factor. Pf is nothing but peak factor in this context. So Kp is nothing but maximum by RMS value. Maximum by RMS value. What is maximum? Vmax by root 2. Is nothing but root 2 value, 1.414. This is the value. Okay. This is what about the pure sinusoid, right? So now second one is half wave rectified sinusoid. Half wave rectified sinusoid, you will be getting half wave rectified sinusoid something like this: 0, pi, 2 pi, 3 pi, and so on. Theta is equal to omega t, V of t, V max. Okay. I told you already what is the standard procedure. First you define time period. What is the time period? Is it pi or 2 pi? It is 2 pi, right? Because the second cycle starts from here. Okay. The second cycle starts from here. The starting point to the point where the waveform starts repeating. Okay, that point you are supposed to identify, and then the difference between these two. Okay, it is 2 pi. Now 0 to 2 pi. We need to define mathematically the given waveform for that complete time period. If you look at this, there are two different signals you can see from 0 to pi and pi to 2 pi. Okay, V of t is equal to, it is a sine nature. Sine nature is always V max sine theta. Don't forget that. Where theta between 0 to pi, or else you can take omega t, also doesn't matter. And 0 because there is no signal between pi to 2 pi. Pi to 2 pi. Understand all of you? Okay? Well, now we need to V average. Find that V average 0 to 2 pi V max sine theta. You already know that it is 0, therefore 0 to pi only I can calculate, and the rest part is what? 0. Okay. If you split that integration into two parts, 0 to 2 pi, 0 to pi Vm sine theta d theta plus pi to 2 pi 0, right? Therefore I'm just neglecting that part, and then if you calculate 1 by pi 0 to 2 pi, already you found that what is the 2 V max by pi, but divided by 2 is there, so final answer will become here V max by pi. Then VRMS will be 1 by 2 pi 0 to pi V max square sine square theta d theta. Understand all of you? Okay. Again simplify it. 1 minus cos 2 theta by 2. 1 minus cos 2 theta by 2. Then integrate it. Then apply the limits. You will get V max by 2. I'm just directly giving the answer. It is your part to calculate. 1 minus here. Okay. 1 minus substitute sine square theta is equal to what? 1 minus cos 2 theta by 2. Then you proceed. Okay. This integration you already know very well. Now form factor Kf is nothing but RMS value. How much non-RMS value? V max by 2. So V max by 2 divided by RMS by average. So V max by pi. This is nothing but pi by 2. You calculate what is that value? Kp. Okay. Maximum by RMS. V max by VRMS. That is V max by 2. Nothing but what? 2. That's it. Clear all of you? Okay. So very important. Note down all of you quickly. Note. Okay. All of you quickly finish that part. And now let's go with full wave rectified waveform. Okay, full wave rectified waveform, the waveform, how does it look like? Third one, full wave rectified sinusoid. 0, pi, 2 pi, and so on, right? So theta is equal to omega t, v of t, this is v max. Again, time period. What is the time period? Where does it start repeating, Nana? From here, right? So therefore, pi, 0 to pi, v of t is equal to v max sine theta for theta between 0 to pi, right? Then what is v average? 1 by pi, 0 to pi, v max sine theta d theta. Already you calculate that value, 2v max by pi, v RMS, 1 by pi, 0 to pi, v max square sine square theta d theta. Okay, you can calculate, you will surely get v max by root 2. So the RMS value of a pure sinusoid and the full wave rectified sinusoid both are same. Average value is not same because the average value of a pure sinusoid is 0. Of course, for the sake of form factor, we have considered half a cycle. Okay, that is only for the sake of form factor calculation. Otherwise, what is the average value of a pure sinusoid is always 0. Okay, so RMS value is same, and the same as now form factor will become what? Kf will also be now similar to your pure sinusoid, 1.11, no doubt, because already we calculated that part with the similar expressions, right? So Kp will also become root 2. You can say the form factor, RMS, form factor, and peak factor values. Note, peak factor values are same for both full wave rectified sinusoid and pure sinusoid. Full wave rectified sinusoid and pure sinusoid. Okay, so note on that. Meanwhile, I just note another problem here. Note down that form factor, peak factor values are same for both full wave rectified sinusoid, and pure sinusoid. Okay. Question number 2 from classroom workbook. Determine average and RMS values. Determine average and RMS values. 0, 2, 4 time t here, right? Say this is the voltage function, 50. It is in volts, it is in seconds. Determine average and RMS values. The standard practice is always, don't forget the standard practice. Of course, I'll tell you simple techniques also, but never forget the standard procedure here, because sometimes the waveforms may be given in a different direction. In that case, you need to go with the usual procedure or conventional procedure only. Okay, shortcuts are important, but not everywhere. Okay, so T first define. What is the T? Hereafter the waveform starts repeating, therefore 2. That means 0 to 2. Now we need to define mathematically what is that waveform. V of t is equal to what? 50 by 2. That is the slope is what? 50 by 2. That is 25. 25 t for t between 0 to 2. Now V average is usually what? V average is usually what? 1 by 2. Okay, integral 0 to 2, 25 t dt. So 1 by 2, 25 into 25 into t square by 2 over 0 to 2. So what do you get now? 1 by 2 into 25 into 4 by 2. So what is this value? 25 only. 25 volts is the average value. Okay. But you also know that average value is nothing but area under the waveform. Is that no? Area over one complete cycle divided by time period. What is the one complete cycle? Area is the triangle. So half. What is the base value? 2. Height value 50. Divided by what is the time period? 2. Clear all of you? Okay. So 2 2 ja, 2 25 ja. So finally you got 25 volts. That's it. So now onwards you can use the area calculation wherever you have a well-defined waveform, triangular, rectangular, trapezoid, all these things you can go. Okay. Now coming to V RMS value, first we go with the standard procedure. Root 1 by 2 integral 0 to 2. What is that? 25t whole square dt. Is it okay? 25 t square dt. Okay. You can simplify 1 by 2 root. What is that? 25. Okay. 25 into t square is nothing but what? T cube by 3 over 0 to 2. Yes or no? So what do you get? 1 by 2 into 25 into 8 by 3. Clear all of you? Okay. This is what actually you get. Now here 2 4 ja. What do you get? 25. Root is nothing but 5. 4 is nothing but what? Root of 4 is nothing but 2. So 5 into 2, that is nothing but what? 10 by 3. 10 by root 3. This is what you get. Yes or no, all of you? Okay. I'm sorry, I think I did a mistake here. 25 square, right? 25 square. 25 square. 25 square becomes what? 25. 25 square becomes what? 25. And 4 becomes 2. Therefore 50 by root 3. Understand all of you? Okay. 50 by root 3 is the answer. Otherwise, you can also go with a different procedure. All of you listen to me carefully here. It's a simple technique. It will save a lot of time in calculating RMS values. Wherever you have ramp, a step, and combination of these two, there is no need to go for this integration part. But we can remember. Okay, this is a simple technique. With our experience, we remember. Okay, it's only remembering. Okay, but it doesn't work elsewhere. I'm telling you. That is why the standard procedure is also very, very important. Understand? Now let us look at this. VRMS can be calculated like this. You generally have step and ramp combinations. Always proceed like this. Proceed like this. Okay? Always proceed like this. What is the procedure? Let us look at. First denominator. What is the time period? What is that value? 2. Now you see in the first cycle, what are the types of waveforms you have? Step function or ramp, or what kind of waveform you have? If it is a ramp, then what is the height of this ramp? 50. So take 50 square by 3. If you have a step, let us say only 50 square. That's it. No by 2 or no divided by 2, no divided by 3. Only for a ramp 50 square by 3. For a step 50 square. That's it. Okay. Now 50 square by 3 into what is the duration of that ramp? What is the width of the ramp? How long it exists here? 0 to 2 only, right? Therefore, the duration is 2. That's it. Simple. You don't have any other, right? Only in the first cycle, you have only one ramp. That's it. If you have any other signal, plus other signal. If you have one more signal, plus another signal. But remember, for a ramp, the height of the ramp, the peak value of the ramp, square by 3 into duration of the ramp. If you have a step, let us say, the peak value of the step, square, into the duration of the step. That's it. Understand? If you follow this logic, I'm sure that you will get the answer very easily. I will also give you that generalized, the rule. So 2 cancel and 50 by root 3 is an answer. Okay. So note VRMS is equal to peak value of ramp square by 3, okay, plus peak value of step square plus and so on, total divided by time period. Don't forget that time period. Understand? Okay. So that's it. Simple. If you remember this, if you have a ramp, apply this. If you have a step, you apply this. If you have both of them, you add them. Sometimes you may get a combination. Ramp, step, ramp might be there. Then again, what will come here? Ramp magnitude square by 3. Again, you will get. Like that, you are supposed to proceed. Okay. So it is a very simple technique. Here it is very simple to calculate even using the integration. But in some other cases, you can save a lot of time if you remember this. Understand? Okay. So therefore, proceed, all of you. Now, question number 3. Find average and RMS values. This is 0, 0.01, 0.02, 0.03, 0.04. This is 0.05. Time in seconds. Voltage in volts. Okay. Now here it is 10. Average and RMS values is asking. Average and RMS values is asking. Okay. I think you have noted down this part, right? Noted down, right? Try this one, all of you. Try this one. Try that problem, all of you. Try that. Now let's look at time period from here to here. 0.03. 0 to 0.03, yes or no? Let's define mathematically what is V of t. V of t is nothing but, look at this. Okay, look at this. A line passing through the origin, constant, 0, yes or no? So all these combinations you have. So what is the slope of it? Slope is 10 by 0.01, nothing but 1000. So V of t is equal to 1000 t. T between 0 to 0.01. It's constant, 10. 0.01 to 0.02. 0 for t between 0.02 to 0.03. Now let's find the V average. What is V average? You can go for integration or you can go for area calculation. Since already we experienced what is the integration calculation, let us directly attack the problem with the simple area calculation. Okay, what is V average? Area under the waveform over one complete cycle. Now this is what the area, and this is the area. Area is 0 here. The area you can calculate because it's a trapezoid. H by 2. What is H actually? 10 by 2. A plus B. What is A? 0.03. 0.02. Okay. A 0.02. B, the width of this particular one will become 0.01. Okay. Plus, what is the area here? 0. Divided by time period. What is the time period? T equal to 0.03. Therefore, gets cancelled and finally you are left with 5 volts. The average value is 5 volts. Now let us find the VRMS. I told you already the simple technique for RMS calculation. Hope all of you remember. I told you already when you have a step ramp combinations. Okay. T is equal to how much? 0.03. 0.03. Now first you have a ramp, then step, then 0, right? Ramp 10. 10 square by 3. Into, what is the width of the ramp? 0.01. Plus 10 square. Step is there. Step magnitude. Into what? The duration. 0.01. Understand? Then what you have? There is no signal. 0. Like that. You can proceed. Okay. VRMS value can be calculated like this. Very simple technique. Or else you can follow integration. You will get the answer. Don't worry. But a simple technique which will save a lot of time. There is no need to go for integrations all the time. Now, even there is no need to define all these things since you already know about it. You can directly attack the problem with what? V average, VRMS calculation. I just gave you as a standard procedure because this habit is very important, because all the time don't expect the problems will come okay in your convenient form. They may change. In that case, when you follow the standard procedure, that will definitely protect you. Okay. Now VRMS is nothing but what actually here? VRMS, what is that value? Now 0.01, 0.01, 0.01 means 3. Now 3 into 10 square plus 10 square, 4 into 10 square, 4 into 10 square by 3 into 3, 3 into 3. So what do you get here? 20 by 3, 6.667. Understand all of you, okay? Because this is 2, this is 10, 20, then by 3, 20 by 3, 6.667. So note down that. Note down that. Hope you like this formula, this method, right? Okay. It will save a lot of time, I'm telling you. Question number 4. Note down that. Meanwhile, I just note another problem here. Another problem. Say this is V of t. It is in volts. Time is in second. The peak value here is given as 5. This is minus 5. This value was given minus 0.01. And this value was given here 0.01. Now you are asked to find form factor. Find form factor. What is the form factor value? What is the form factor value? Clear? Can you try? Can you make an attempt? What is the form factor formula, Nana? Form factor is nothing but what? RMS value by average value. Simple. RMS by average. But what is the average value of the given waveform? If you go with the standard procedure, what I explained, you are supposed to define the time period first. That is always important, whether you follow shortcut or general method. Okay. But you need to define the waveforms. Yes or no? Mathematically, you need to define the waveforms. So what is T actually? If it is starting from here, now it starts repeating from here. 0.01 minus of minus 0.01, the time period is 0.02. You need to define mathematically 0 to 0.02, 0.02. What are the waveforms? It is a line with an increasing slope. This is a line with a decreasing slope. So starting point x1, y1, x2, y2, find the equation. x1, y1, x2, y2, find the equation. Then go for the integration. It will take a lot of time. Yes or no? You will get the answer, don't worry. Then RMS also similarly. Square of that particular function and then integration. Takes definitely time. Let's go with our calculation. With a area calculation. Now, V average, strictly speaking, it is 0. No doubt. Because it is a symmetric waveform. Look at this. Look at this is a symmetric waveform. Yes or no, all of you? It is 5, minus 5, 0.01. Definitely this is going to be minus 0.005. This is going to be plus 0.005. Yes or no, all of you? Like that it will go. So for finding the form factor, we have a common practice. Only for a half cycle we find. Yes or no? Only for a half cycle we find. V average over a half cycle is equal to, you get, what is a half cycle? First let us try to define. If you take it as a starting point, then it looks like the waveform repeats from here. If you take the starting point here, then it looks like the waveform start repeating from here. Is that all of you okay? So definitely we need to take half cycle such a way that that area is not going to be 0 again. Suppose if you select this part, what is happening? Half cycle means this is a half cycle. Suppose if you take this one is a starting point, this one is a starting point. Now look at this. This is another point which repeats. So where is the half cycle? This is a half cycle. If this is a half cycle, then the area again becomes what? This area becomes same, positive and negative. Both will get cancelled. Finally, even if you take half cycle, you are getting the area 0. So what will you do then? You cannot go for a quarter cycle again. It's not possible. Only half cycle. But half cycle you select in such a way that that area is not going to be 0. So you have so many ways to select the cycle. Yes or no? One cycle can be selected from here also. If you select this particular one, half cycle, this area is not going to be 0. Positive region completely. So let me select, this is what the waveform, so that the half cycle when I select, this area is not going to be 0. Hope you understand the point. Only a half cycle I am selecting. Time period is very clear, 0.02. Time period is 0.02 because only half cycle you are taking, right? 0.01. Yes or no? The difference between these two is what? 0.01. Half. Base 0.01. Height into 5. That's it. Get cancelled and 2.5 volts is the answer for V average over a half cycle. Understand? Now what is V RMS value? VRMS, you never get 0 because you're taking the squares, right? Now, time period, what is that? 0.02. Now you select the waveform, whichever the waveform you like, this one, whatever. If you select this, first it starts from here. This is the ramp. What is the ramp height? 5. 5 square by, what shall I take here? By 3. Yes or no? Into, what is the duration of this ramp? 0.05. 0.005, I'm sorry, 0.005. Next ramp. Okay, don't take up to this part. In this method, you are not supposed to take the total ramp like this. This is another ramp. Then this is another ramp. Then this is another ramp. Then this is, like that you are supposed to proceed. But of course, our starting point is here and ending point is here. We get 4 ramps. Don't say 1, 2, 3. Okay, you can't say 3 ramps. You have 4 ramps. You are supposed to take individual. Understand all of you? In this method, the precaution is that one only. Okay, that is the precaution you are supposed to take. Okay, then what do you get here? This is also 5 square by 3 into what? 0.05. This is also what? Minus 5. But square you are taking. Again 5 square. Divided by 3. Into. The duration is what actually between these two? This is the ramp, right? The duration is how much here? Again 0.005. Now this is another ramp. Again 5 square. That means there are 4 such kind of similar ramps are available with the same height, with the same width. That is why I put it, okay, 4 here multiplied by 4, because there are 4 similar kind of ramps are available. I think all of you understand this. It's a very, very important. If you don't follow this method and you follow integration, I'm sure that it will take a lot of time. This will cancel. And 5 by root 3. Understand all of you, okay? So what is the form factor on here? RMS by average. 5 by root 3 divided by 2.5. 2.52 ja. So 2 by root 3 is a form factor. If you want, you can calculate it. You'll get some answer. Probably 1.16. Please check once. 2 by root 3 is the answer. 1.16 is the answer. Okay. So I'll give another problem. Just note down that problem. Meanwhile, I just note down another problem here. Fifth problem. Fifth problem. Understand all of you, okay? Hope you understand this. How I applied, how I got into 4 such ramps are there, similar ramps, right? Ramp magnitude square by 3 into 0.05005. Like that we proceed. Understand? Now after that, let's go with another problem here. V of t is equal to a plus b sin omega t plus c sin 3 omega t plus and so on. Like that you have d sin 5 omega t. Like that it is getting repeated. You already know that how this waveform is resulted. How this waveform is derived. You have already seen using the Fourier series expansion. When you have a sine wave with some harmonics, you can analyze it using Fourier series expansion. Fourier series analysis you have. So if you apply the Fourier series analysis to a sinusoid function which contains some harmonics, the result is like this. Yes or no, all of you, okay? Understand? So for this result, I would like to find the average and RMS values. Find average and RMS values. Let me find the average. What is the average? V average is equal to, since you know that this is a sine wave, totally what sine wave? So what is the time period of the sine wave? The time period of sine wave is what? 2 pi. Yes or no? So therefore 0 to 2 pi. So 1 by 2 pi, 0 to 2 pi, a plus b sine omega t plus and so on plus. Okay? You go like this, right? Now d omega t. You are supposed to take d omega t. You know that this is a constant value a into omega t, because d omega t is there, omega t. But omega t substitute what? 2 pi minus 0. So 2 pi gets cancelled. Finally, a only you are left with. Plus, what is this value? Sine wave. Pure sine wave, when you integrate over 0 to pi, it is 0. Next, 0 and so on. So finally, you got a only, right? What is a? Actually, the constant value. In this particular function, this a is called DC component. DC component. So what is the average you got for this entire function? You got a, that is nothing but DC component. That is why, okay, that is why, note. average value is also known as first point is also known as DC component of a given waveform. Average value is also known as DC component of a given waveform. Second one, RMS value is also known as effective component or AC component of a given waveform. Okay, RMS value is also known as effective component or AC component of a given waveform, because when you have an AC function, okay, you may have some DC component also. So what is the effective component that you can find using? Usually called effective component, not exactly AC component, but this is applicable only when AC waveform is given. So instead of remembering like this, better you remember effective component of a given waveform instead of remembering like, AC component of the given wave, because sometimes it gives a contradiction also. Okay, so that is why better you remember RMS value is the total component or effective component or total component. Okay, total component, the whole component, or effective component, like that you can define. It's a very, very important point. Then similarly, RMS value. If you take VRMS, what do you get now? 1 by 2 pi. So what do you get? The whole square, 0 to 2 pi, A plus B sine omega t plus C sine 3 omega t plus and so on, whole square, d omega t. So what will you do? What do you get? How do you simplify that? Finally, we remember the answer, no doubt, but let us also look at how we get that answer. Finally, we remember the answer. But sometimes the derivation is very important. In understanding purpose, in the gate point of view, don't worry, the derivation is not important. Okay? So what do you get? For example, if I simplify, only A plus B sine omega t. Because I can say this is A, capital A. So this whole part is capital B. Then what do you get? A square plus B square plus 2AB, right? First, let me simplify this. Then based on that, I will generalize it. So if I take A plus B whole square with A square plus B square sine square omega t plus 2AB sine omega t. Is that all of you okay? So for this, you are supposed to apply the integration. When you apply the integration to this part, this particular part, only A, capital A. I'm taking capital A and this is the capital B, okay? So what do you get here? When you take the integration, now A square omega t, when omega t will become what? 2 pi minus 0. SR null of 2 by 2 pi will get cancelled. Again, it is like a DC component. This is a DC component. So finally you get what? A square. Clear all of you, okay? In the integration, you have a constant value, that is A square plus. You know that sine square omega t, already we found 0 to 2 pi V max square sine square omega t d omega t integration, RMS value, VRMS, you remember that? All of you? VRMS square, what do you get here, actually here? Tell me. V max square by 2. Yes or no? You got VRMS is equal to V max by root 2. But finally I can write VRMS square, okay, is equal to what? V max square by 2. Yes or no, all of you, okay? V max square by 2, because I'm not applying the root 8 in this, because within that only I'm applying here. So therefore, if I simplify this part, I'll get B square by 2. Just like Vm square by 2, okay? Within the root only it is there, right? That is why because you get something like this. You get something like this. Otherwise, you can say like this. Okay? This is nothing but V max square. V RMS square is equal to V max square by 2. But what is there within the root component here? V max square by 2. Plus this value, because sin omega is 0 2 pi, it is becoming 0. Like that, if you go on simplifying that, you have C, then D, then E, like that. C square by 2 plus D square by 2 plus and so on. Therefore, you will get now, this is actually 0 to 2 pi. D omega t. You got this. Therefore, now V RMS will become, I generalize, A square plus B square by 2 plus C square by 2 plus and so on. Whenever you have a sine wave with some harmonics, this is the third harmonic components are available and all second harmonic components are nullified. You are left with only third harmonic component. Okay, odd components you have. Okay, so I think you understand this formula is very, very important. In exams, 1 mark questions are coming repeatedly on this particular formula. Note down that. I can give you one simple question example that V of t is equal to 3 plus 4 sine omega t plus 4 sine 3 omega t. Then what is the average and RMS values? So what is the average value? V average is always a DC component. What is the DC component? 3 volts. What is VRMS? What is VRMS? 3 square plus 4 square by 2 plus 4 square by 2. Yes or no? So 4 square by 2 plus 4 square by 2 is nothing but 4 square only. 3 square plus 4 square and root. This is 5 volts. Clear? Clear all of you? Hope you understand this, all of you. So no doubt. No doubt. So I read the question here, all of you. Go for the 6th problem. A full wave rectified sinusoid is clipped at 0.707 times of its maximum value. Find average and RMS values of the resulting waveform. Simple. Okay. Find average and RMS values of the resulting waveform. It's a full wave rectified sinusoid and it was clipped at 0.707 times of its maximum value. And what is the average and RMS values of the resulting waveform. I told you already, whenever the data is given about average and RMS, first you define it mathematically. The waveform is not given, but from the data given, we can understand what is the waveform it is. It could be how it looks like. I have drawn here already. Look at this, a pure sine wave, a full wave rectified sinusoid. Then it was clipped at about 0.707 times of Vmax. Then for this, we require average and RMS value. So if you want to find that, you need to really find where, the waveform is clipped here 0.707 times. That means definitely it is possible at pi by 4 because it is Vmax by root 2. Yes or no? Vmax by root 2. For what value of the sine wave? Okay, or at what instant the sine wave is going to be Vmax by root 2, Nana? Definitely pi by 4. At this angle only, right? So 3 pi by 4. This is pi. Then pi plus pi by 4, 5 pi by 4, 7 pi by 4, and so on and so forth. Like this you are going to get. So let us take only one cycle here. What is the cycle? Pi, 0 to pi. Okay, we need to define it mathematically. V of t is equal to, what is V of t? Tell me. What is V of t? 0 to pi by 4. It is a sine nature. Sine nature. Therefore, sine nature is what? Vmax sine theta. Don't say Vmax by root 2 sine theta. Vmax by root 2 is not the maximum value. Maximum value is always Vmax. Vmax by root 2 is the point where the waveform got clipped. So you can't take the point where waveform got clipped here. This is always the maximum value. Understand all of you? Okay. Wherever you clip, the maximum value remains maximum value only. It may not reach that maximum value, but by definition, the maximum value of any sine wave, definitely it is going to be Vmax. So the nature of the waveform is always Vmax sine theta. Theta is between 0 to pi by 4 and 0.707 times. So the Vmax by root 2 is nothing but for theta between pi by 4 to 3 pi by 4. Okay, so the definition of this waveform mathematically is very important here. After that, the answer is very, very simple. So you get here now again Vmax sine theta for theta between 3 pi by 4 to pi. Now if you apply V average is nothing but 1 by pi 0 to pi. What is this? Vmax sine theta 0 to pi by 4 sine theta d theta plus pi by 4 to 3 pi by 4 Vmax by root 2 d theta plus 3 pi by 4 to pi Vmax sine theta d theta. Okay, like that you can calculate. Similarly, RMS also you can find. Okay, I give the answer. You can simplify it. And similarly for RMS also you can write the expression. What you get? Square root 1 by pi 0 to pi by 4 square all squares. Okay, you can simplify that. But I give an answer 0.approximately 54 Vmax. You're supposed to get. Similarly, VRMS value will also be 0.584 Vmax. Okay, these are the answers you can take directly, and you can calculate. I'm telling you, you must be good at the integration. Okay, I stop the session here. Note down that quickly.